Now we will work on different trig equations. What makes trig equations hard is that there's three of them. If you followed along and have watched these videos, in 12, 13, 14 weeks, I've only told you, hey, you must remember maybe two, maybe three formulas or equations. Well, now I'm about to hit you with three in one day. And I don't want to scare you. I don't want to be mean. But if you don't remember these equations, you're not going to be able to do trig. So that's, like a scary point to some people. And, again, it's just one of the things you have to remember. Sine, cosine, tangent. Sine theta simply says sine theta is equal to the opposite side over hypotenuse. Cosine theta is equal to the adjacent side over hypotenuse. Tangent is tangent theta is equal to opposite side over the adjacent side. Now, the purpose for this is it allows us to find a side of a right triangle when we only know one side in an angle measure, or if we want to find specific angles of a triangle only knowing the sides. So anytime we do trig, we want to make sure our calculator is in degree mode. You can do trig in Desmos. What you have to do is come up here to your wrench, and instead of it being in radians, you need to flip it 2 degrees. If you do that, you'll be just fine. Okay? So, Sokotoa, pyramids. I don't particularly care for them. I just remember these. Sokotoa. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. However, I know that some of y'all use these in science and you like them, so I figured why not put them in these notes. So cover the letter for whichever is our unknown value and either multiply for horizontal or divide for vertical. Okay, so multiplying left to right, dividing for vertical. What I like to do is think of it this way, is OH CAH TOA, right? And I'm going to have to know both the opposite hypotenuse or the adjacent hypotenuse or opposite adjacent to use the particular equation. So again, I'm pretty sure we have a bunch of questions. So what I want y'all to do before we actually start solving these things is go through and actually just write down what we're going to be solving for. Are we going to be solving for an adjacent side, or are you going to be solving for an opposite side, or are you going to be solving for a hypotenuse? So what I mean, and again, I'll do a couple examples just, to kind of help us out. So number one, again, just label hypotenuse, right? And I know this is a leg, and I know this is a leg. However, that's not helpful now because I don't know my hypotenuse value, and I also don't know a leg value. So legs are not specific enough now. This is where being able to trap the angle that's not 90, and from there either say adjacent or opposite. Well, I have the adjacent here and the opposite here. And from here, what I do is figure out what am I solving for. Well, again, we solve for variables. Our variable that we're going to be solving for is opposite. All right. And number two, again, find my right angle sign, draw my arrow. This is my hypotenuse. Find my angle, I trap it. When I trap my angle, it touches the adjacent. The remaining side is forced to be opposite. What am I solving for? Find your variable. 10 is a number, it's a known value. 25 is a number, it's a known value. Don't have anything for my hypotenuse, and I look over here at opposite, it's x. So again, I'm solving for my opposite side. Last one, number 4, draw my arrow, label and mark my hypotenuse. I see an angle that's not 90, so I trap it. When I trap it, it touches the adjacent and hypotenuse. I'm never going to get these mixed up because I always label my hypotenuse first. This forces my last one to be the opposite side. Again, what am I solving for? Find your variable. My variable is x. I'm going to solve for the hypotenuse. So like I said, go back and do the remaining questions just on figuring out what are we going to be solving for. We're going to be solving for the adjacent, the hypotenuse, or the opposite side.